Okay, have you ever been stuck between two choices? Paying more right now for something that's going to last versus saving a bunch of cash up front on a cheaper option? Today, we're diving into something called engineering economy. It's this really powerful way of thinking that helps you make the smartest financial call pretty much every time. So let's jump right in with a classic problem. Picture this. You're an engineer, and you've got two different designs for a brand new machine. One of them has a lower sticker price, but is it really going to cost you less over its entire life? This is exactly the kind of puzzle engineering economy was made to solve. All right, so here are the two options on the table. Option A is cheap to buy today, but you know you're going to be shelling out cash for repairs and maintenance for years to come. Then there's option B. Whoa, big price tag up front, but this thing is built like a tank. So, which one is actually the cheaper choice? Well, the answer isn't so obvious because the real trick is comparing money you spend today with money you're going to spend way down the road. To figure this out, you can't just stare at the price tags. Nope. You have to be able to compare the value of that money across time. And this is where you learn to think like an engineer economist, using both your technical brain and your financial smarts. And that brings us to the single most important, the absolute core idea in all of engineering economy, the time value of money. So what is it exactly? Well, the official definition is that it's the change in the amount of money over a given time period. But really, it's just the simple idea that money's value isn't fixed. A dollar today is not the same as a dollar next year. Understanding that one difference is everything. Let's just put it as plainly as possible. A dollar in your hand right now is way more valuable than just the promise of a dollar you'll get next year. And this isn't just a gut feeling, it is a fundamental economic fact. And why is that? Well, it really just boils down to two big reasons. First, there's opportunity. You can take a dollar today, invest it, and watch it grow into more money. That's a missed opportunity if you get the dollar later. And second, there's inflation. Prices go up, so that same dollar is just going to buy you less stuff in the future. Okay, so if we know money's value changes over time, how in the world do we actually measure that change? Well, that's where interest comes into the picture. I absolutely love this quote from our source material. It says, "Interest is the manifestation of the time value of money." It's just perfect. Interest is the engine that actually drives this whole concept. It's basically the fee you pay to use money, and it's the thing that makes a dollar today equal to, say, $1.10 next year. Now, there are two main ways interest gets calculated. You've got simple interest, which is super straightforward. It's only calculated on your original starting amount, the principal. But then there's compound interest. And that, my friends, is where things get really, really powerful. It's interest on your interest. Let's see how this plays out. Let's say you borrow $1,000 for 3 years at a 10% simple interest rate. The math is pretty easy, right? You pay $100 in interest each year. For 3 years, that's $300. Add it to the original loan, and the final amount you owe is $1,300. Simple enough. Now, using those exact same numbers, watch what happens with compound interest. After year one, sure, you owe $1,100. But in year two, that 10% is calculated on the new, larger amount. So the total jumps to $1,210. And by year three, you're paying interest on the interest you already owe, bringing the grand total to $1,331. And when you see it side by side like this, it just clicks. Okay, it may only be $31 over 3 years, but stretch that out over longer periods. And the power of compounding is just dramatic. It's the force that builds fortunes. And if you're not careful, it's also the force that builds some serious debt. All right, so we've got our core ideas down. Money's value changes, and interest is how it changes. So now let's put this stuff to work and see how it actually helps us make smart, real-world decisions. The tool we're going to use is called economic equivalence. And all that means is that we can compare different amounts of money at different points in time on a totally fair apples-to-apples basis. Using a specific interest rate, we can figure out what some future amount of money is worth today, or what an amount today will be worth in the future. It's like a time machine for money. So let's get back to a real-world problem pulled straight from the source material. A company needs new furniture. They've got a choice. Spend $14,500 today or wait a year and spend $16,000. Now, here's the key. Let's assume this company could earn a 12% return on its money if it invested it somewhere else. A little cash flow diagram like this really helps us see the problem clearly. we've got money going out and outflow of $14,500 at time zero, which is just fancy talk for today. And we have another option, an outflow of $16,000 at the end of year one. The question is, how do we compare these two? And this is where economic equivalence works its magic. The trick is to bring both of those costs to the exact same point in time so we can compare them fairly. So let's figure out the future value of spending that $14,500 today. See, if the company just held onto that cash instead, they could invest it and earn 12%. So 1 year from now, that $14,500 would actually be worth $16,240. That is its equivalent cost in the future. And just like that, the choice becomes crystal clear. We compare the equivalent future cost of buying now, that's $16,240, to the actual future cost of buying next year, which is only $16,000. So by waiting, the company actually saves $240 in equivalent value. The math literally makes the decision for us. So what's the big takeaway from all this? Let's wrap it all up and summarize your new economic toolkit. First, and this is the big one, always consider the time value of money. $1 today is not $1 tomorrow. Second, never ever underestimate the power of compound interest. And third, use the idea of economic equivalence to make fair, data-driven comparisons between your financial choices, especially when they happen at different times. And as a final, incredibly useful tool you can use every single day, let me give you the Rule of 72. It's this fantastic little mental shortcut, a back-of-the-napkin trick, to estimate how long an investment will take to double. All you do is divide the number 72 by your annual interest rate. That's it. For example, let's say you're earning a pretty good 10% return on an investment. How long till it doubles? Just take 72 divided by 10, and you get 7.2 years. It's a simple but really powerful way to get a feel for the long-term impact of compound growth. So we'll leave you with this question. Now that you have these tools, the time value of money, the power of compound interest, and the handy Rule of 72, what big financial decision in your own future, whether it's buying a car, saving for retirement, or starting a new project, what will you now look at completely differently?